Basic Education, Department of Education, Republic of South Africa, National Senior Certificate, Grade 12, Mathematical Literacy, Paper 2, November 2024. Paper written today, which was 150 for 3 hours. Let's go into the questions. Question number 1. Table 1 below contains a list of explanations and definitions of concepts used in mathematical literacy. Table 1, explanations and definition of concepts. Now they want you to match. You should get used to this as we go on. All right, this is, the first one is a measurement. It's a measurement of, they're telling us a measuring system using meters, liters, and kilograms. We know this one as it's metric. So this is metric. Then they're telling us an amount of space occupied by the object. This is volume. As a measuring system in inches, gallons, and pounds, this becomes imperial. Then the amount of space available to hold. This is what we call capacity. A side of a building, you see when you are facing south, side of building, you see that when you're facing south, this has to be the southern elevation. Southern elevation. Then we go to the side of the building, you see when you're facing north, this has to be northern elevation. Northern elevation. Then the amount of space that is enclosed in an enclosed, this has to be area. So here we go, we say 1.1.1 capacity, we've seen it as D. 1.1.2 northern elevation, we are seeing it as F. 1.1.3 imperial system, we are seeing it as C. And 1.1.4 area, which is G. Area, an enclosed space by perimeter. 1.2, paving blocks are available in different shapes and sizes. Hexagonal paving bricks are made up of 6 equal triangles. Hexagonal, this simply means the 6-sided. Hexagonal equal triangles, and will be used to cover a rectangular ground surface. This is how it looks like. All right. These are the dimensions that we have there. Okay. They're telling us to convert 222 millimeters into meters. Millimeters to meters, we divide by 1,000. So this is supposed to be 220 divided by 1,000. And the answer becomes 0.22 millimeters. 0.22 millimeters. Choose from the option A, B, or C below the correct one that could be used to calculate volume. Take note of that. Volume over the hexagonal paving brick. Now here we shall, in your head, you know very well that the volume equals to base area times what? Times height. And when you look at this, is 6 times area of the triangles. Sorry, area of the triangle. And indeed, the base is made of 6 triangles. So A was the best answer here. Using the theory of base area times height, that's how we get volume. Base area times height. We come to question number 1.2.3. Calculate the number of bricks needed for a single row along the length of 2,860 millimeters. So now, since they're going to be put on the length, and what covers the length, it's the width of the paver. So it's the width there. So the paver will come, sit there like that. So how long will it be? So we're going to say we shall divide the 2,860 divided by the width of which is 200. So when we divide that by that much, we end up having 13 of them. 13 of them. 1.3. The fold-up chair is a bench chair that folds into itself. A 3D sketch, a side view, a material list, and the assembled chair and the folded up chair shown below. Write down the total number of wooden items needed to assemble this chair. Now what we're going to do, items are here, but we are looking for wooden. We need 4 chair supports, 13 cross pieces, sit back bottom cross pieces. Now, so the cross pieces are these blocks that you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So they're already 13. Then the supporting ones are these ones that we saw already. 1, the other side 2, 3, and 4. Wooden. We are looking at wooden. So in other words, what we shall need here to do is to add the 4 and the 13. 4 plus 13, which becomes 17. The sit back, bottom, cross piece, these are just items that make up one chair. Okay, we're continuing and you're looking at determine the number of cross pieces found on the seat of the three chairs. That we are looking at the cross pieces. So if there are 13 on one, what about the 3? We shall multiply by that, we shall get 39. Someone else would have done this, still get the same answer. Name the item in the material list with the longest dimension. The longest dimension. Now they're telling us the longest dimension. Item with the longest dimension. So there's supposed to be the chair supports. Chair support. Because that's the longest. Look at that. 66. We have 36 and 32. The chair supports or chair support. Identify with dimension. Identify which dimension of the chair support will represent the thickness of the wood. Thickness of the wood, they have told us, it takes the smallest value. Then when you look at all these values here, the smallest 1,9. So we shall say which dimensions, we shall just write 1,9 centimeters. 1,9 centimeters. 1.3.5. Write down in millimeters the length of the spacing between the cross pieces of the back of the chair. So here they have already showed you in the diagram here. Remember seeing them here. The cross back is here, the spacing. It's this one here. They want it in millimeters. So It will be 1,27. Those were centimeters. We want them to become millimeters. That means we are going to, they want it in millimeters. We are going to multiply by 10. And the answer becomes 12,7 millimeters. Question number 2. John and 5 other family members decided to participate in leopard trial run. They decided to camp at the pigeon camp site there. They're telling us use an next A. Use next A shows the aerial view of campsite and the number of campers allowed. Some campsites have one hut and others have more than one hut, labeled A, B, and C. Annexure A. Use annexure A and the information above to answer the questions that follow. So this is the annexure. So it goes to the question. It says, explain what's meant by an aerial view. An aerial view is the image seen from above. An aerial view is seen from above, or some people call it the bird's eye perspective. The bird's eye perspective. That's another word from. These are usually pictures taken by drones from above. Okay, calculate the maximum number of campers that can be accommodated at this campsite. We are going to add all the numbers that we know there. So we're going to add, first one takes 6. Let's add them from here. The first one takes 6 plus 15 plus what? You're going to add these numbers here. Add them up. And when it comes to these two, we take the maximum. It's because it says 4 to 6, 4 to 6. So we take 6. Okay, let's add and we say, we shall add 6 plus 15 plus 4 plus another 15 plus another 4 plus a 4 there, plus a 5 plus a 5 plus a 15 plus 8, 10, 6, 6, and a 20. And the end of the day, we have the total as 118. 118 campers. Determine the general direction of the dam from campsite 8. They sing from campsite 8. So now you're here, campsite 8. You want to go to the dam. So if this is the north, east, south, and west, this combination here to give us southwest. So we shall say the general direction there was supposed to be south, southwest. You're from camp 8 to the dam. The description below is found on their website. This campsite is situated near the dam and can accommodate a maximum of 19 campers. Write down the campsite. Write down which campsite is being described. Write down only the number. Now, which campsite can accommodate 19? We just come here, you just add up. These are 6, 5 plus, this is 19. Nothing else. Because this is 23. This is a 5. So we are looking at campsite 2. So here we're supposed to write campsite 2, but I said write down only the number of the campsite. All right, calculate as a percentage the probability of John and his family randomly selecting a hat that can exactly accept the whole family. Exactly accept the whole. Now remember, it's John and the 5 other, so in all there are 6. So which camp has 6 exactly? So remember, we are determining probability. So it's camp number 1. So out of how many? Out of 9. So the answer there is supposed to be probability. The answer is supposed to be 1. 1 out of 9. 1 out of 9. They said as a percentage, then multiply 1 out of 9 multiplied by 1 out of 9 multiplied by 100. 1 out of 9 multiplied by 100. Exactly. Oh, wait, let me see. Yeah, exactly, yes. One out of 9. Which is 7.11%. 7.11%. So we continue and we are looking at this. They are telling us the layout below shows the ablution facilities, the toilets and the showers. Ablution simply means cleaning, the places where you can go and clean yourself, or restrooms, all right? In the middle of the campsites 3, 4, 5, and 6. The actual length of the ablution facility is 8.2 meters. All right, then we go and they are telling us, write down the total number of showers. This was so simple. You have to just count and find that we have 1, 2, 3, 4, 5, 6, 7, 8, and they are 9. So here we are saying 9 showers. 9 showers. Determine, round it to the nearest whole number, the scale of the plan. Now, here you had to use your ruler. Why do we need the ruler? Because the scale is supposed to be left is to right, which is on paper versus actual measurement. You already have the actual measurement, which is 82 millimeters. So you had to come here, measure from here up using your ruler. For me, when I measure, when I put my ruler here on the computer, I get 90 millimeters. That means 90 millimeters are equivalent to 8.2. You know what? Because I'm looking for the scale, I need to change the meters to millimeters. So I multiply by 1,000. So it's going to be 90 is to 8.2 times 1,000, which is 8,200. Divide by 90, and divide by 90. So here I remain with 1 is 2. 1 is 2. Remember, they told me to round off to the nearest whole number. 1 is 2. 91.1, 1, which becomes 1 is to 91. Leave it like that. All right, we go to the other question. Give one suitable reason why benches are found in the ablution facilities. One, someone might be waiting. Waiting to use. So they sit there to wait. Waiting place for any empty facility. 2.2. Leopard trial run is two-day event. Run on the outskirts of the camp, starting and ending at Caldera Falls home base. Annexure B shows the map as well as the elevation map of the Leopard Trial closest to Wilmore. Okay. Visitors to the site camp can also do a 4-day hike starting at the Calendar Falls home base. Here we go. Day 1, we have the trial run. Day 1 trial run is day 3. Day 4 is hiking. Day 1 of the trial run is day 3. Day 2 of the trial run is days 1 and 2 of the hike. Trial pass through the natural landscape. Anyway, write down the day during the run when you will pass. Take note of that. You will pass the Gabriel's pools. So we go to the next term. Let's go to the next chair here. So this is the next chair. So the Gabriel's pass the pool, it's this side here. And this is day 2. They're telling us right down the day. And we are saying day 2. The descriptions of a part of the road on the brochure are as follows. Run 5.5 kilometers along the Rubik Valley, then continue down other side of the reflection pools for swimming and drinking water, then turn to the home base. So here they're asking us, choose the route described above and match it with A, B, C, or D. Write only the letter next to the question. But we are seeing it's from here. From there, they're saying 5 comma. It's day 2. Day 2 part 1, day 2 part 2. So here it's D or C. John's best average speed in kilometer for the run was his average speed from the 8 kilometer mark up and 18 kilometer mark up on day 1. All right, so here we are looking at 8 markup, and 18. But these two are not showing on they're not either showing on the elevation, not even showing on the map. So this question here has some missing information. Use the elevation map to explain why this was the case. Now, when you look at the elevation map, there's no way we see 8. There's no way we see 18. Because this is 20, this is 15, 10, and 5. So there's nothing like that. John stated that day 2, while he was running Rome 17.5 kilometer mark to the end of the trail, he had moved more than 100 meters closer to the sea level. Show by means of calculations. So now we shall take at 17, what distance was it? That's what we have to know. This is it, and the distance is around here, which was 1,050. Minus when he came down here, at what level was it? It was 900. So which is 100 and what? 50. And it's valid. It's more than 100. It's more than 100. Day 2. That's what we are looking at. In day 2, this is where day 2 is. Okay, question number 3. Mrs. Kamgo is a grade 2 teacher at Happy Valley Primary School. She has a reading corner at the back of her classroom. Learners who wait for their transport after school usually sit there and read a book. Mrs. Kamgo stores pillows in bags, as shown in the pictures below. Learners sit on these pillows after school. We are looking at this piping, thin cord covered in fabric used to decorate the bag and the reinforcement of the same. Okay. The school day ends at 12:55. Tetandi's father was late and he only came to fetch him at 14:13. Determine how long Tetandi's father, how long Tetan sat in a reading. So simply meaning you have to do this. You had to subtract that and you ended up having yes, we have the answer as 1 hour, 18 minutes. 1 hour, 10 minutes. Okay. So they're telling us the height of one pillow is 11 centimeters. Determine the difference between the total height of the pillows in one bag and the height of the bag. Now look here, we are looking at the difference between the total height of the pillows in one bag. So we shall come here and ask how many pillows are there. So we have 1, 2, 3, 4. So the difference we need to subtract. It will become 48 minus 4 times 11, which becomes 4 centimeters. So question number 3.1.3, the piping around the bottom edge of some of the bags for the pillows needs to be replaced. The store sells the piping in half-meter lengths. Calculate the total length of piping you'll have to purchase to replace the piping around the bottom edge of 4 bags. Now, first and foremost, piping, this is length, it's associated with perimeter. So we're going to find out only one bag, how much perimeter how much length does it need? So it's 30 by, remember they're saying bottom. So it will be 30 and 46. So we shall say perimeter equals to 2 into 46 plus 30, which became 46 plus 30, you have 125. These are centimeters. You see that? But then for 4, we multiply by 4. multiply by 4, that's only for 1, then you multiply by 4, so you have 608. This is still centimeters. Remember, they say they are sold in half-meter length, all right? So we need to change this into meters. We divide by 100, you get your 6,08 meters. So they're asking you, like the total length of piping, you will have to purchase, to replace the piping at the bottom of the edge of the phone. Length you should have to purchase. So when you go to the shop, they sell in half meters, 0.5 meters. You buy one. All right. So how many of these shall we need if we have 6,0? How many of half meters shall we need? Okay, yeah. That's what we want to cover. So how many shall we buy? How many half meters shall we buy? So it will be 6, the length that you got for the one that you need, divided by 0.5. Which is 12,16. That meaning you're going to buy 13 of them. You're going to buy 13 half meters. Though the 13th one won't fully be used. 3.2. Mrs. Como created a birthday calendar for her 2024 class to hang against to hang against the wall. She'll write each learner's name and birthday on a small circular wooden tag and attach the tag to the correct mark. A circular wooden tag has a circular hole to attach a ring that is used to hang. The tag area of the circular hole is this much. This small hole has an area of that much. Every year she paints the front surface area of the circular wooden tag. The spread rate that she uses is 6 meters squared per liter. So we are coming here, we are saying determine in centimeters the circumference of the circular wooden tag. Circumference equals to pi d, which is 3,142 times the diameter. The diameter that we have is 8. The diameter we have there is 8. So 3,142 times 8, you get the answer as 25,14. These meters, sorry, these are centimeters. These are centimeters. All right, they're telling us, determine in centimeters the radius of one circular wooden. So the diameter is already 8. You're determining the 8, the centimeter, you divide it by 2. So the radius is 4 centimeters. 4 centimeters. Then we are looking at 3.2.3. This it claims that 50 ml can of paint will be sufficient, will be enough to paint one side of 36 circular wooden tags. Verify her answer showing all calculations. Now, first and foremost, we need to find out the area of that. And it has to be in meters, because the reason why we need for it to be in meters, the spread rate is in meters. meters what? Squared. So let's change, since it's area, so it's pi r what? Squared. So the 4 is we need to divide by 100. So this becomes 3,142 times 0,04 squared. We have the 0,4, it comes from this. I was changing centimeters to meters because of the spread rate that we're going to use. All right, this is the answer there. So we end up having 0,050272 times the 36. So we multiply by 36. So we have the area to be 0, comma. But remember, this, there's a certain part, the hole is not going to be painted. We need to subtract the area of the hole, this one here. We need to subtract that one there. So whereby we shall subtract. Oh, these are centimeters squared. So we need to change them into 0,142 centimeters. We need to change them to centimeters cubed, whereby we divide by 100 squared, 0,3142, 0,3142 divided by 100 squared. I'm changing them from centimeters. Yeah. Answer becomes too way small. I'm writing everything here because the answer is too way small. So it's this answer that I'm going to put here. I was changing from centimeters squared to meters. So we've ended up having 0,0 about 5 meters what? Squared. Yet the spread rate that we have is 6 meters squared per liter. Per liter. So we need to divide this. We divide this by 6, which makes it worse. These are liters. I want them to become milliliters because I'm proving with milliliters. So multiply it by 1,000 and I will get 0,8 milliliters. The statement is valid. The statement is valid. Let me see the other way around. Let me see. Or the other way around, you would have said area of that circle there, which was supposed to be pi r what squared, which is times 4. Leave it. We're going to calculate it in. We're calculating it in centimeters squared first. So here we end up having this much. So we get this, we multiply it by 36. Oh, wait. We get that, we subtract the area of the hole, which was 0.3142. Subtract that and we say that minus 0.342, you end up having 49.57. These are centimeters what squared. Then multiply by 36. Multiply by 36, remain with 1798.48. These are centimeters what squared. We want them to become meters squared because we are using the scale factor, sorry, the spread factor that tells us if you only have 6 meters squared, you use 1 meter. So we need to divide this by 100 squared, because I'm changing centimeters too. So I'll divide by 100 and I'll get my 0.1798 meters what? Squared. So I need to find out now how many meters will I use here. I'll divide by 6. I'll divide it by 6. I have it at 0.02997. These are liters. I want milliliters. I multiply by 1,000. Multiply by 1,000 and I got the answers 29, which is approximately 30 mils. And still the statement is what? Valid. Because 30 mils are less than 50. So the 50 mil can will be enough. Question number 3.3. On each learner's birthday, the learner receives a cubic-shaped packet of homemade sweets, as shown in the diagram and the picture below. The diagram and the picture below. So they're asking us the volume of the cubic-shaped box is 2,744. Calculate the size of the side length of the cubic-shaped packet. This one here, we don't divide by 3. Rather, because this volume here equals to side times side times side. So this side is the same as volume equals to side cube. So if you already have volume as this much, what one side that produced it 3 times? We look for the cubic, and the side here became 14 centimeters. 14 centimeters. We looked for the cubic root. . There are 35 different colored sweets in the packet. Determine the probability as a decimal of randomly choosing a pink or a yellow sweet. That means we're going to add pink and yellow. Pink, there are 8 plus 7 out of the 35 as a decimal. We are going to look at that soon. This is 15 out of 35, which is 15 divided by 35, 30 out of 7 as a decimal to be 0.4285. But we usually round off to decimal places, it becomes 0.43. So ability is 0.43. Question number 4. Question number 4. Question number 4 says, crude oil is heated in a vertical cylindrical tower to separate the extract products such as petroleum gas, gasoline, which is petrol, kerosene, which is a lamp oil, diesel, industrial oil, and paraffin wax, which boil at different temperatures. Cylindrical tower. Oh yeah, the cylindrical, on the left, we have the cylindrical tower showing different products and their boiling temperatures. And on the right, we have a diagram of the vertical cylindrical tower. So you're saying the extraction and everything is there, you see it, and say, identify the crude oil product that will be third to boil. So the first one is at 20. This is 1, 2, 3. We can't start at 400 as it goes to 20. Definitely it starts from 20 as it goes up. So now the one at 400 degrees Celsius, this one's the last one. So 1, 2, 3. So here, 1, 2, 3, we have kerosene. This is the third one to boil. We have calcium. Lamp oil. Write down the products extracted at 150 degrees. 150 degrees, we have gasoline, which is petrol. Petrol. Convert the boiling point of diesel to degrees Fahrenheit. This was a little bit tricky for some people, but others it's fine. First and foremost, we need to make this understandable. Actually, you can also make it under whereby you can say C equals to F into brackets minus 3 over 2 divided by 1,8. Or the easiest way to do it since there's a denominator, this denominator has to jump over the side. So it will be C times 1, that, giving me the Fahrenheit minus 0. So I already have the centigrade degrees Celsius for diesel. So I will come here. I look at diesel. Diesel is this one here, the 300. 300 diesel. So we shall come here. We say we put the 300 here. Multiply by 1,8 multiply by 1,8, and we add. We shall add on the 32 because this 32 it has to jump over the side, and because you're looking for f, it has to remain alone. So 32 has to come or to jump over. So here we end up having 572 degrees Fahrenheit. The pipes leading in and out of the vertical cylindrical tower take up 2.5% of the surface area of B, of surface area of part B of the cylindrical tower. Calculate the total surface area of the vertical cylindrical tower, excluding the area taken up by the pipes. Excluding means we're going to subtract. So they're telling us the surface area of an open cylinder is the same as pi diameter times what? Height, which is okay. So we shall say 3,142 times what's our diameter? The diameter they told us it was 6 meters. Times the height, which is what? 54. The height, 54. And the diameter is 6. So we go on and you see. So here the answer became 1018, 01. These are meters squared. Meters. So now this is B. So that's the surface area of B. So of B, we need to know the surface area of the pipes. So we shall subtract. You can take it this way. It's fine. Look for the area of the pipe, so multiply it by. Multiply by this. I'm looking for the area of the pipes. End up having the area of the pipes is 25,5 what? Meters what? Squared. So this is the pipe. So the final answer is going to be 1018,01 plus the area of A and C, which is 150 plus 150,81 minus 25,5,45. 101,018,01 plus 150,81 minus 25. So here the area is 1,143,37. These are meters what? Squared. So the same calculate the total surface area of the vertical. Yeah, this is it. This is it. Four point two. A worker at the oil refinery intends converting her double door garage into a bigger living room by building a double wall to replace both the doors. Replace both the doors. Then we go on and we say, in complete diagram, it's that much. They're telling us determine the total number of pallets of bricks needed to replace both the garage doors. Now, here there was also a little bit of, I don't know, there's a little bit of missing because they've not given us how many bricks are needed. So I believe you would have come here and you would have counted to find that because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and I will count this one at 10. Either it faces and because that's the other side. So what about here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So all in all, we need 20 bricks going up and 10 laid down. Becomes 200 bricks, but it's a double wall. Multiply by 2 to get 400. Get 400. So they're asking you how many pallets are needed here. So definitely, if you need 400 bricks, you shall need 1 pallet because a pallet has 525. Okay. The opening of the garage has a dimension of 2,13 meters by 3 meters. Other costs, they build a double brick wall. You have material other than the bricks, which will cost 2,000. Labor, which will cost 500 per meter square, a square meter. The owner states that the total cost to replace both the garage doors with the wall would be 15,200. And they're asking us verify her statement by means of calculations, whereby you may use the following A. So definitely, you're looking at cost, you have to buy the bricks. These bricks will be, because each is sold differently. So each is 645. You buy the bricks. You have to buy the other material, which is 2,000. Then the labor part. So the area that's going to be covered, we need to know it. Area to be covered, they are telling us it's okay. We shall multiply 2,1 times 3, which becomes 6, which is approximately 7. So 7 times the 500. 7 times the 500. Then afterwards we add on the 2,000. Okay, the 2,000 already there. Okay, let's see how much will the bricks cost us. Sorry, cost her. The bricks are costing 3,386.25 cents. The 2,000, it's already there. Plus the 500 times this, 3.5. When you add 3,386.25 plus 2,000 plus 3. We shall have the answer as 8,886, 25. And we shall say the answer is invalid. They say the answer is invalid. Give one suitable reason why the bricks have to be placed on a wooden pallet. You can say for easy carriage. They're easily lifted, carried from one place to another. Question 5. Next, just see. Chris and Babo are planning a year-long trip, mostly along the A1 motorway around Australia. It is the world's longest continuous road of 14,655 kilometers that passes through every state and connects 7 of its 8 capitals. So we are looking at annexure C. Annexure C is the map of Australia and the distances and driving times between the major cities and the states or territories. Next to it is a plan of their trip. So we come to 5.1.1. We are looking at annexure C. Annexure C, here we come. There we go. The planned route, they will start from somewhere here, Feb, March, come back, May, move around. Okay. They're asking us, write down the names of the cities where the distance between them is 738 kilometers. So we come here, we look at all this distance. The distance was here between Melbourne and Adelaide. So here it's supposed to be Melbourne. Name 4 months when Chris and Purple will be in Western Australia. So now, Western Australia is here. When you check very well, it's here around here. You know? So you can say August, September, October, and November. We are saying August, September, October, and November. Determine the distance between Perth and Alden. Determine the distance. Determine the distance between Perth and Alden. So here we are. Now you check very well that the distance here, others are given, but the distance from here to here, it's not given. Just giving us 29 hours. So what you're going to do, we shall subtract all the other distance from the total distance that they gave us in the scenario. We shall subtract all other distances. Other distances. Okay. The scenario here, they're telling us we have a distance of 14,000. So let's come here, we shall say 14,000, 14,600 minus 18701 plus 2811 plus 2850 plus 1705 plus 922 plus then we shall subtract that and we see. This gives us the answer as 2,696 kilometers. 2,696 kilometers. Name the state where they plan to be in during February. This is Feb. Which state is situated here? The state is represented by this. They plan to be in February. The state of Victoria. The state of Victoria or Tasmania. Because there are two states that are here. This is not that much clear, but you see, forms a triangle here. All right. We can say Victoria or someone who talks of Tasmania. Calculate the average speed in kilometers per hour from this place here to other. So here we have to go to the map, first and foremost, identify the places. They're asking us between this and this. So already the distance is there and the time is there. When you look at the question paper, they have told you distance equals to speed times time, but they want you to get speed. That's why we remember the triangle to make our life easy. So our speed here, speed equals to distance over time. And make sure the distance is in kilometers and the time fully hours. Let's go there. I'll do it from here. So the time had to be 20. I need to change the 40 minutes to hours. I divide by 60. So 20 plus 40 over 60. I end up having 20,67. These are hours. So the distance given to me is already 1,500. It's already in kilometers. So the speed was supposed to be so we get the speed as that much. We divide it by 20,6. And it's hour. 82.49 kilometers per hour. That's the speed. We come here and we say, Chris and I plan to visit Ulu. This is oval-shaped big rock. Rises 100, or, sorry, 1,142 feet above the surrounding desert plain. A picture of Ulu is shown alongside. That's how it looks like, the diagram below. So now it's the height is being compared with these other items. So they're saying determine rounded off to 3 decimal places. The conversion factor from feet to meters using a diagram in the form of 1 foot is. So now what we're going to do, we want us to get a now in meters it's this high, you see, and in feet it's that high. So what we're going to do, let's put feet, because I want 1 feet is equivalent to a given number in meters. So we shall put the feet, on one side, which is 1142 equals 3, 4. So these are feet and these are meters. Since we want one to be this side, we shall divide through by 1,142 on both sides. This goes with that, remain with 1. 1 foot now equals to 3, divided by 42. Remember they said in decimals, so 3 decimal places. So 0,304, so it becomes 5 because there's a 7 here. So that is the answer there. 1 foot is equivalent to 0,305 meters. Right as a simplified ratio, the heights of Hulu, the Leaf Tower, and Big Ben in a ratio. So now, what is going to happen here is that we shall say yes, using your calculator, you can compare 2 of them. Let's see, if we divide through by 3, divide through by the smallest value. When I compare the smallest value and this one here, I get 29, and here I get 8. So I need again to compare 32 divided by 96. I get 8 and 27, so this is it. So this is simplified ratio. 29 is to 27 is to 8. 5.3, it says, in addition to the mainland, Australia is surrounded by many thousands of small islands. Okay. All right, here we are asking us, a rock from the sky fell somewhere in Australia. Write down the probability that it is randomly, that it randomly fell in Queensland. Queensland, this is out of how many? Because here we only have 1 Queensland, 1. So how many places are there? So we have 1, 2, 3, 4, 5, 6, 7, 8. So the probability here is going to be 1 out of 8. 1 out of 8. I just want the probability. I didn't say as a percentage or a decimal. So 5.3.2, show with calculations why it could be stated that the total area of the islands of Australia is approximately half the area of mainland area of Tasmania. Tasmania. So we shall come here and say approximately half. So we're going to say, what's Tasmania there? It has this much. Divide K. So we shall say, this is it. The answer becomes 3215 divided by 68401. Just do that and you see what happens. It gives 0.47. Then if you round off, this is approximately what? Approximately a half. Using calculations could be stated that the area of the sure, approximately a half. So this is all you have to do. 5.3.3, the Australian Capital Territory has a population of 454,499. Determine rounded to the nearest whole number, the population density of Australian capital as people per what? Kilometer square, per square kilometer. So the people are these ones here. That means the people are going to be divided by the area of Australian territory. So we shall get this number here, divided by 2358. It becomes 102.75, but we are looking at humans, so which is give a suitable reason why the calculation is omitted. It's because when you add these, they give you 100%. And the one is that this one is also too small, and it misses the island part of it.